You are used to seeing that for quadratics, yeah? If you complete the square, you can put it in what they in your book are calling standard form. Some people call it vertex form. It's just a little bit different. Okay, and that's what we're going to work on today. Most of us are used to working with vertical parabolas. They can also be sideways. So I'll show you that as well. All right. So let me show you what all the hubbub's about here. Yeah, that's what I said. Okay, there's a sideways parabola. Just like ellipses, hyperbolas, circles, we have a bunch of values that we can calculate based on that. Let's see, where do we start? Let's start with the focus. We're going to start with the vertex, actually. The vertex is HK, just like everything else, the center, so the foci, etc., or the center. Okay, so the vertex is the center, quote unquote, of the parabola. From there are two things we can do. There's this value called P. P is the distance from the vertex to the focus and the vertex to what we call the directrix. These vocab words ringing a bell a little bit? Nope. And then we have the last one is the axis of symmetry. All those will contain all the information we need. The focus on a horizontal parabola. What do I do to change the vertex to get the focus? What do I add to the x value? P, right? So it's h plus p. Y value stays the same. Still k. And the directrix, h minus p. No k because it's a line. It is a line at this x value, vertical line. So there's the equation. This one would be x equals 2. Okay. And the axis of symmetry is y equals, what's the y value? Okay. And for a parabola of this nature, here is the standard form. Of the equation. Notice that it's the y that's squared this time. You okay, Hatcher? Yeah.
do you find what P is?
P is, okay, two ways. If you're given the graph, it's the distance from the vertex to the focus, or the vertex to the directrix. It's a number. If you're given the equation, I'll show you one in a minute. It would be 4p equals 8, or something of that nature, and you can calculate p. Okay, so let me give you an equation here. Let me try to find a good one. Yeah, I'm just going to go with that one. Let's look at that equation there. This will be an example. So we'll calculate all these values. Based on the fact the y squared, it's a horizontal parabola, right? And is it open to the right or to the left? Why? Yeah, it's positive. You got it. So what we need to do is get it in this form. Left side okay? Yeah, what's the k value? 0. Thank you for making it easy. What about this side? The x has to be by itself. How are we going to get it by itself? Factor in 8 out. Okay. Now we're good. So that's the equation in standard form. Yes. 2 times 4. Yep. What's the vertex then? I'll give you the 0. -6. There you go. Because it's x minus h, so if it's positive, you have the opposite there. Focus. H plus P is? Nope, it's on these ones, the x values are what's changing. So it's -6 plus 2, H plus P. Okay. Directrix. Somebody said it. -6 minus 2 is -8. And the axis of symmetry. Y equals K, which is 0. Okay. Nice. Okay, we can graph it now. So the axis of symmetry, y equals 0. Directrix, x equals -8.
focus there, and vertex there. And notice that this is the p-value, 2 and 2. I'm not going to require you to be perfect on these, but just give it a sketch. Does anybody know how a parabola is built? We built the ellipses with the string and the two foci, right? If we were to do something similar with a parabola, what you end up with is any distance that's perpendicular, it's from the parabola to perpendicular to the directrix, is congruent to the distance from the focus to that same point. Mine is not drawn correctly, as you can see. It needs to be wider. Okay. But those two distances anywhere on the parabola should be the same. Focus to any point to the directrix perpendicular. So that would be the easier examples. Are we okay there?
Sure.
Can I move on? Okay. Do you want me to put down the vertical version?
Yeah.
Okay, let's do that then. Vertex is always HK. So what's different about the focus? Yeah, by how much? Okay, plus P, yep. So the Y changes. And then the directrix, same deal. And then the axis of symmetry, pretty straightforward. X equals H. Pretty much got it. The equation. Yep, the X is squared. Or P times Y minus K. Good. Good. Got it written down? One person. Okay. All right. So I'm going to give you a little bit more difficult one. It's not even close to the format that we need. X squared minus 8x minus y plus 18. We are going to have to complete the square to get it in this form. So notice that I need my y's over here, correct? So I'm going to move this to the right. And leave yourself a little space here, because we're going to have to complete the square. How do I complete the square? The over 2 squared goes here and here. It's -8. So what's this going to be? 16? So we get so I've factored here. It's -4 and -4 to get multiplied and added. So x minus 4 squared. Now are we good? No parentheses. If you want, you can do this. Does that make it easier? Okay. For some of you, maybe. Some of you didn't need it. P is 4p is 1, right? So what's p? 1/4. Yep. If you need to set that equation up, feel free. Now, you can go through and the vertex is HK 4, 2. Focus. Yeah, the y is changing. So 4. Yep, add it to the y. P plus K. Directrix. Y equals K minus P. And the axis of symmetry x equals 4. Do you want me to show you the graph? If you're comfortable with this, I'll write the homework down. If you need to see the graph, I will do that as well. So that's due tomorrow. If you need the graph, here it is. Directrix. There you go. Any questions? Beautiful.